So Eklutna 2019, that's location 19, and we just made one hole here.
Braving high winds and freezing temperatures for science. A team of geologists have made the long trip from Ghent University in Belgium to assist the USGS with new research at Eklutna Lake.
Got it. Trove. Looking good.
This is recording the history of the lake through time.
The team is taking 30 core samples from the 6-mile stretch of lake in hopes of finding a natural recording of the earthquake that rocked Anchorage and the Mat-Su Valley in late 2018.
In lakes, there's annual layers of sediment that are a lot like tree rings.
If there's something from 2018 earthquake, it's going to be up there.
Previous research at the same lake has already allowed the team to identify irregularities in the lake bottom caused by the Good Friday earthquake of 1964 and a dam break that took place at Eklutna Lake back in 1929.
Cores that are, a couple of feet long or so. We've probably got, it's about 100 years of history, something like that. But we've got cores that are almost, they're probably about 55 feet long. And we know that they go back at least 3,600 years. And you can have this annual record of things that happen in the lake and in the environment. And all that helps to make for good science, which can make for a safer place to live. So this is one of these cores that we collected last winter from Eklutna Lake.
Got it.
In the past 9 months,
Looking good.
these core samples from Alaska have made their way around the globe, carefully packaged
Oh yeah, this is stinky.
to protect evidence of the November 30th earthquake's impact on sediment beneath the lake's surface.
So there's 1995. As far as our understanding of earthquake hazards in south central Alaska, these really giant earthquakes like the 1964 earthquake, we know that they occur only several hundred years or more apart. But we've often thought that these smaller earthquakes, like what happened about a year ago, occur quite a bit more often.
So that's where Lake Eklutna comes in.
We have evidence to believe that this is the Anchorage earthquake right up here. Those sediments are a little bit like tree rings. This shows where we collected cores, or all those little dots.
Häusler and a team of researchers from Ghent University have been able to catalog the deposits of sediment across the span of the lake's bottom,
So we can get enough resolution to see these deep.
locating 2 separate underwater landslides, along with several other historic geological events.
And then we think this is 1995, 1989, 1964, and then the rate of deposition slows down in 1929 at the very bottom.
Soon, this and a bulk of the other research done since last November will be published in an issue of the Seismological Research Letters.
To the lake. Paper on ground failures, kind of landslides, ones on building shaking in various ways, basin amplification, how Cook Inlet can cause some of the shaking to be larger here.
That timely publication, near the 1-year anniversary mark, is partially coincidence and partially driven by circumstance.
There's definitely the sense that we got to collect data that's going to go away. Certainly in the case of this earthquake, there's a lot of ground cracking, but within a week of the earthquake, the ground was covered by snow.
Häusler estimates that scientists have probably learned around 80% of everything that evidence can teach us about the earthquake, but the research is still far from over.
One thing we really want to know better in the Anchorage area is how often this type of earthquake occurs. So we're going to do some additional studies this coming summer. In many ways, much of what happened was in fact what we expected.
Hank Davis,
In many ways, it feels like we dodged a bullet.
Channel 2 News.
Talking about the